Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group.
In this video, I will discuss about traction mechanics. This topic is included in Unit 4 of the subject Utilization, Traction, Heating and Drives. Subject code is EE/S5/UTHD. In this video, I will discuss about traction mechanics. Now first we discuss about units used in traction mechanics. Units used in traction mechanics. So units of distance, speed, etc. used in the mechanics of train are altogether different from those used in solving the problems of ordinary applied mechanics. Now various such units used and their notations are capital D is equals to distance in kilometer. Distance in kilometer. V is the speed in kilometer per hour. Okay, next alpha or beta. This is acceleration or retardation in kilometer per hour. Next W, weight in tons. T, time in seconds. F, tractive effort or force in newtons. T is the torque in Newton meters. So these are the units used in traction mechanics. Distance in kilometers, speed in kilometer per hour, acceleration or deceleration in kilometer per hour, per second, weight in ton, time in second, tractive effort in Newton and torque in Newton meter. Next we discuss about type of service. Types of service. Types of service. Now there are three types of passenger service which traction system has to cater for, namely urban, suburban and mainline services. Service. Now in urban and suburban service, the distance between the stops are very small, and fast speed schedule can only be achieved with high acceleration and braking. And this is made possible by the use of equipment developing high tractive effort. Now, fast speed schedule enables more trains to run on a heavily loaded route, or alternatively a given traffic can be handled in less number of hours. Or on mainline service, distance between the stations is very long, and therefore high balancing speed are desirable. For this, moderate acceleration will be adequate unless there are large number of speed restrictions. So first I write down the parameter. First parameter is acceleration. Okay. Now for urban service, it is 1.5 to 4 kilometer per hour. For suburban service, it is 1.5 to 4 kilometer per hour, similar to urban service. And for mainline service, it is for mainline it is 0.6 to 0.8 kilometer per hour per second. Okay. Now next parameter is retardation. So for urban service, it is 3 to 4 kilometer per hour per second. For suburban service, it is similar to urban, 3 to 4 kilometer per hour per second, and for mainline service, it is near about 1.5 kilometer per hour per second. Next, maximum speed. Next parameter is maximum speed. Now for urban service, it is near about 120 kilometer per hour. For suburban service, it is similar to urban service, 120 kilometer per hour, and for mainline it is 160 kilometer per hour. Now distance between station. Our next parameter is distance between stations. So for urban service, it is 1 kilometer. For urban service, it is 2.5 to 3.5 kilometer, and for mainline service, it is more than 10 kilometer. Now for urban service, free running period is absent, and coasting period is small. For suburban service, free running period is absent, and coasting period is long. And for mainline service, long free running and coasting periods. Long free running and coasting periods. Now acceleration and braking periods are small comparatively. Now this is the comparison of these parameters: acceleration, retardation, maximum speed and distance between stations for urban service, suburban urban service and mainline service. Okay, now on goods traffic side there are three types of service. In a good traffic side, there are three types of service, namely mainline freight service, local or pickup freight service, and shunting service. Now mainline freight service consists of long distance trains usually fitted with continuous braking. Some of these trains may have speed of 90 km per hour. Local or pickup freight traffic is used for collecting and delivering goods stored at a central and marshalling yards and operate for short distance around large towns, cities and along branch lines. And shunting service is used for sorting freight traffic in large marshalling yards, and motive power for shunting service is operated at low speed. Train movement. Speed, time, curve. We discuss about. A train is to be run between two stations most optimally as far as possible. For this, it is necessary to know the speed time curves, the resistance to motion of the train, both the frictional and windage, and then it is possible to find out what energy must be supplied to the train to perform a particular job. Now, by taking various speed time curves, we can calculate the energy requirements, and that particular speed curve can be followed, which gives minimum energy requirements or a similar function for which the train movement is being stipulated. Now, speed time curve is a graph showing the variation of speed as a function of time. Variation of speed as a function of time. In general, motion of the train can be classified as acceleration, constant speed, and coasting. That is running with power switched off, and therefore there is a retardation due to frictional and windage forces, and the last is retardation, and this is due to braking. Now the movement decided the shape of speed time curve. The slope at any point of the curve gives the acceleration or retardation of the train at that instant of time, and the areas between the curve and the time axis up to a certain time gives the distance covered by the train until that instant of time. Now, if the slope is positive, it is an acceleration. If it is negative, it is retardation, and if it is zero, the speed is constant at that instant of time. So, first I draw a typical speed time curve. This is speed, y-axis represents speed and x-axis represent time. Now first is notching up period. Now first is notching up period. T1. This is 0, this is T1. This is rheostatic acceleration. Okay. Now during this period of run, starting resistance is gradually cut, so the motor current is limited to a certain value. And to cut the starting resistance, handle has to be moved from one notch to another, and hence the name given to this period is notching up period. Now tractive effort is defined as the force in newtons exerted by driving wheel on the rail to produce the movement, and sum of tractive efforts exerted by all the driving wheels of a locomotive is called gross tractive effort, which is proportional to the combined torque exerted by the motor. Now motor current during the notching up period fluctuates between certain maximum and minimum limits, and therefore torque developed by the motor and the tractive effort also fluctuate. Next is the acceleration on speed curve. Next is the acceleration of speed curve. T2, or we can say speed curve running. This is the acceleration. Okay, now when all starting resistance has been cut out, tractive efforts exerted by the motor is more than the train resistance, and the difference of the two is responsible for further acceleration of the train. And we should however mark one difference between the acceleration, which is constant during the speed 0 to T1, and the acceleration which decreases with speed during the period T1 to T2. Now three factors are responsible for the decrease in acceleration. First, speed torque characteristics of series motor in such that as speed increases, torque developed reduces. Second, as speed increases, train resistance increases very much, and this reduces the net tractive effort available for giving acceleration. And third cause is speed increases. As the speed increases, coefficient of adhesion decreases, and therefore the portion of the torque exerted by the motor which is usefully converted to tractive effort is reduced. Now the speed of the train will continue to increase to a speed at which tractive effort is equal to the train resistance, and train then will continue to run at maximum speed. Now next is free running period, T2 to T3. This is free running. This is free running period. Okay, now during this period the trains runs at constant speed attained at the end of the speed curve running. Next is the coasting period T3 to T4. This is T4. This is coasting period. Now at the end of free running period, supply to motor is cut off and train is allowed to run under its own momentum. And due to train resistance, speed of the train gradually decreases. And last portion, this is T5. This time is T5. T5. And this period is known as braking period. Braking period. Now at the end of the coasting period, brakes are applied to bring the train to stop. This first portion is known as rheostatic acceleration or acceleration while notching. Then the second period is known as speed curve running or acceleration period. And from T2 to T3, this period is known as free running period. The speed of the train is constant in this period. Then T3 to T4 is known as coasting period. Now in this period the train running by its own momentum, and at time T4 to T5 this period is known as braking, and the brakes are applied to bring the train to stop. Okay, so this is the speed time curve, and this curve is divided into rheostatic acceleration period, speed curve running period, free running period, coasting period, and braking period. Okay. Now in case of urban service where the distance between consecutive stop is less than 1 kilometer, the free running period may be absent, and it is desirable to have relatively high speed so that a good frequency of train service is made available. Therefore, high value of acceleration and retardation are maintained with a short period of coasting in order to other reasonable saving on energy consumption. An acceleration of 4 km per hour per second and retardation of about 6 km per hour per second is recommended. And similarly with suburban service where there is relatively longer distance between station, the coasting period is longer but free running period is again absent, and in order to have frequent service of trains, high values of acceleration and retardation are required. And typical values of recommended are 2.5 km per hour per second and 4 km per hour per second respectively. And mainline service is characterized by the long period of free running at high speed, and the accelerating periods are unimportant as they are short as compared to the total run of the train. And for suburban train running on level track, the coasting retardation is approximately 0.16 km per hour per phase. Next we discuss simplified speed time curve. Simplified speed time curve. Now in order to make actual speed time diagram to calculation, simplified speed time curve are taken in such a way to cause least error, and at the same time calculation are made easy. Okay, now first we draw the simplified speed time curve. So this axis represents speed and this axis represents time. And this is O, this is A, this is B and this is C. Now OABC is the actual speed time curve, and the basis of constructing the simplified time curve keep both the acceleration and retardation values same, and the areas under actual and simplified curve, that is distance between station, also same. Now in case of simplified trapezoidal speed time curve, now this is A double dash and this is B double dash. Now O A double dash, B double dash, C speed curve running and coasting periods are extending. And this is A dash, this is B dash. And the trapezoidal speed time curve gives closer approximation of the condition of the mainline service where long distances are involved, and quadrilateral speed time curve for urban and suburban services. So first we derive the expression for trapezoidal speed time curve. Next we derive the expression for quadrilateral speed time curve. Trapezoidal speed time curve. This is O, A, B, C. This is T1. This is T2 and this is T3. Okay. This axis represents speed and x-axis represents time. This is Vm. Vm is the maximum speed attained. So time of acceleration, that is T1 is equals to Vm by alpha seconds. Now alpha is the acceleration per kilometer per hour per second, and Vm is the maximum speed in kilometer per hour, and time of retardation, that is T3. T3 is given by Vm by beta. What is beta? Beta is the retardation coefficient, retardation in kilometer per hour per second. Now total distance D is equals to area of OABC. Okay, now to D is area of OABC. So we can divide this total area into OAE. E is this point and this point is D. So OAE plus AEB, AEB and BEC, BEC. So this area plus this area plus this area. So we get the total area OABC. Now this is equals to OAE plus DEB plus BEC. Okay. Now AEB is equals to DEB by the properties of trapezoidal, and this is equals to OAE plus CBD. Now this is equals to half AD into OE plus half BE plus BE into DC, and this is equals to half VM T minus T3 by 3600 plus half VM T minus T1 by 3600. Okay, now this equals to VM by 7200 2T minus T3 minus T1. This is equals to VM by 7200 2T minus VM by beta, and T1 is equals to VM by alpha. Now VM by 7200 2T minus VM is 1 by alpha plus 1 by beta. If we take common, minus VM. So we consider a constant K is equals to alpha plus beta by 2 alpha into beta. So D is equals to VM by 3600 T minus VM into K. Or we can write KVM square minus VM T plus 3600 D equals to 0, and from this we get the value of VM. This is equals to T plus minus root over T square minus 14400 KD by 2K. Now positive signs gives very much higher value of VM, which is not possible in practice, hence negative sign is adopted. So the final value of VM is T minus T square minus 14400 KD by 2K. Now from this equation, D is equals to VM by 3600 T minus VMK. Suppose this is equation 1 and this is equation 2. Equation 1 we can write D is equals to VM T by 3600 minus VM square K by 3600, and where K is equals to 3600 by VM square by VM into T by 3600 minus D. So therefore half 1 by alpha plus 1 by beta is equals to 3600 by VM square VM minus VA by VA minus 1, and VA is the average speed. So 1 by alpha plus 1 by beta is equals to 7200 by VM square VM by VA minus 1. In the next video, I will discuss about quadrilateral speed time curve.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.